So we have how much time? 3 more minutes before we start. So let's do some, not Kahoot. I'm tired of Kahoot. We should do just polls, right? Like live polls, because I want to know who I'm talking to. I want to know who's here today. So how many of you are programmers? Can you raise your hand? Almost all of you. All of you are programmers. Nice. I'm talking to programmers today. My people. Okay. And how many of you know Go programming language? Can you raise your hand? So quite a few of you. This is good because today's talk is very introductory to Go. It means you don't need to know Go, but after this talk, I assure you, you'll go and learn Go. So today's talk is not that hard. It's introductory. So I'll make sure that you understand everything I say. But if not, feel free to interrupt me. I have a microphone. You can, take it and ask questions. And like even after the talk, feel free to come by and ask in person or just ask in the audience. It's okay to ask questions. It's important to ask questions because you're questioning things is what makes it more interesting. And I'd love to hear your thoughts on the topic as well. So we have a few more minutes. Like people are coming. And we have 2 more minutes before we start. All right. So a few people on the back. Do you need chair? Maybe you can bring chair from the other rooms. Yes, let's get them chair because this talk is 45 minutes long. That means standing up for 45 minutes is good for me, but not so good for you. So, who is backend developers here? Can you raise your hand if you're a backend developer? Oh my God, that's like more than half of you are backend developers. And who is front-end developers? Can you raise your hand? Like less than half of them are front-end developers. This is good. Our talk is not just backend or front-end. It's both. It's like end-to-end because when you're building a real-time application, there's no such thing as like real-time backend and real-time front-end. There's like they come together. Only if they are both real-time that makes your application real-time. So it's 1 minute. Let's start sharp at 3 p.m. Shall we? So it's like waiting for a new year very soon. I can get started. Anyways, I think it's time. So today's talk is building real-time apps with Go. And thanks for coming, all of you. Very glad to see all of you. Let's do introduction. This is my terminal, right? Like this is how I see my terminal every day. Who am I? I am Azim Pulat. And where do I work? My host is right now Google Cloud. I work at Google Cloud. And let's ask the cow, what's my team? So if you say cow say, there's such command in terminal, right? In Linux systems, the cow says Kubernetes control plane. I come from Kubernetes, so I've been working in Kubernetes for over a year now. It's been great at Google. So yeah, there we go. So I'd like to start the talk by asking one simple question. What's the best way to learn? Yep. Maybe you saw my slides. Yeah. It's learning by doing it. There's no better way. I'm telling you, there's no like 40-hour course on Udemy, right, which teaches you like real-time systems. No, like the best way to learn is go by do it. And reinventing the wheel. Like people say, oh, this application already exists. Why are you building it, right? Like I know it exists. I know the developer who built it, but I never built it. So I want to take the chance to build it. So if it's something is built already, doesn't mean you shouldn't build it. Go build it. Like, reinventing the wheel will give you the chance to improve the wheel in the future, right? Like if you don't reinvent the wheel, you're not gonna build the car. So today's talk is based on this idea of doing it, right? Like you have to do it, not just watch the talk, but we're gonna like see things as well. Monkeys are simple, monkey see, monkey do. Like we should be like monkeys, right? Like monkey see, monkey do. And we can say developer see and developer do. So I'll show you some things. I'd like you to see it and do it right? Like, it's that simple. You see it and you do it. So whatever you're building, you should build something hot, right? Like, what's so hot these days? So hot, right? Like, it's LLMs. LLMs are so hot these days. People are talking about LLMs. They're building wrappers on top of them. Like, they're building their own training, fine-tuning. Like, LLMs are so hot right now. And how do LLMs work? This is not my talk, by the way. We're not going to speak how LLMs work. But how they work is they predict the next token, right? Like, they predict the next word. They're really good at this. That's how they work, right? Like, they say LLMs are so hot right now. You've seen this, right? Like, you've used ChatGPT, likely. And if you were like me, you would say, how does it work? Is it like faking it? As if like it's spitting out word by word, right? Like, I thought so, but no. They're actually, models are slow. And if they immediately show a word at a time, it's so much better user experience. And imagine if it was taking like loading time for 15 seconds and then all of a sudden showing exactly paragraph. How bad user experience would it be, right? And ChatGPT is one of the examples where like making your application real time makes it way more valuable, way more user experience, like much better user experience. And when I used ChatGPT, I was like, wow, how is it working, right? And if you are like me, you open DevTools. Have you? Have you opened DevTools in ChatGPT? Okay, a few people. Like, when you open DevTools, what you're going to see is the API called conversations, right? Like, there's a bunch of tokens coming. And there's a part that says event stream. That means it's streaming events. Like, every token is coming at some second or millisecond. Like, anytime model has predicted the next token, it's just sending to frontend. And frontend is displaying it. It's not like waiting the entire time, like 30 seconds, and then giving it all as a response, but instead it's streaming it. And streaming, what makes applications real time? If you can stream your events to your front end, that means your application can be real time. And let's see how we can achieve this using Go. Let's write our first server, because we need a server before a client. And let's write our first line of code in Go. And it starts with package. Like, any Go code starts with a package. And it can have its own name if it's a library, or it should be main. Main means you can execute it, you can run it. Just like other languages like Java, C, like main means you can execute it. We can import our dependencies, and Go is such a cool language that allows you to have everything in standard library. If you want to build a server, you don't go import Express or like request library. No, you import directly from your standard library. Like NetHTTP has everything you need to build a good server, right? Like useful server. So you import NetHTTP library, and we write our main function. That's when our code executes. That's what it runs. We're just parsing the flags. Don't worry about this. We don't need this. So we're registering a handler. This is a function, home. It doesn't exist yet. And then we are running the server. It's listening on a port and running the server forever. If it doesn't crash, it's going to run forever. And our handler, which is registered at home, that means if user enters this URL, we're going to respond this. And this is hello world. That means if you open now your server in a browser, if you connect to your server, that's what you see. So much code for this result, right? But we'll get there. Now let's stream events. How do we stream events? In Go, it's much simpler than any other language out there. Like, let me show you. So we are adding an additional handler, which means like if you go through this route, the /events, that means it's going to handle your events. The same way we handled was homepage. And this is the first line you should write whenever you're streaming events. What does it say? It says we're changing the header. We're adding a header, adding content type as event stream. What does it say? Content type is what we're responding to the client, right? Like it can say, okay, this is a JSON, this is a XML, this is an HTML, this is a picture, right? Like this is what the type is, and the type is event stream. That means now client is going to see and understand what the type is. So you need this line. Without this line, your server is not going to respond in real time. And I just made just random strings here. but you can get them from your model, like GPT model or any model that you have, and it comes through a channel. If you're good at Go, like there's something called channel. It's like a queue. So it's like anytime it's ready, it's like a generator. Anytime something's ready, you can get it. And you can iterate over it. And whenever we're iterating over something, we can prepare our content. We're just formatting it. That's how you formatting Go. We're just formatting with a prefix of data colon. It's like in RFCs that's defined that you should have this prefix. Otherwise, it's not seen as an event stream because we are following this exact specification. And we just give this as a formatted string, and we write it to response. What's the response? W is, if you go here, I know Go uses 1 letters, but you just go there, and it says response right there. So that means we're writing to the response every time we have a token available, we're just writing it. You think this works?
Yeah, so basically we are returning bytes, right?
Yep.
We are having the text event string. Should we return text?
You don't need to return. In Go, you don't return. In other languages, you return response. In Go, you write to response.
Okay.
The Go is different, right? Like it gives you a response writer, and you call this write method. You write, and that means it's writing to the response. We don't return anything. And you're seeing that there is no return type here. So whenever you write, it's not written immediately to the connection that the client has opened, but instead it's written to somewhere called buffer. What's a buffer? It's an intermediate place where you keep all your responses, and we flush it only after the function has exited, right? Only after function has exited, you flush it, just like the toilet, right? Like you flush it. And you need to flush earlier. That's how we do it. We just cast it into flusher, and then we call the flush. I know it's a bit weird, but that's how you should do if you want your content to be written immediately. If you want your content to be written immediately to the real connection, not the buffer, you call flush. Buffer is like an intermediate array where you keep all the response, so that imagine you're writing a lot of content, like in a for loop. How Go actually makes it faster is that it waits for you to finish writing, and after you finish writing, it will write to your client. So we want to cheat this, like we want to skip this. That's why we call flush. This is very important to make the thing real time, because otherwise, if you just remove this line, it will still write it, but you will receive it after all of them have been written. And then we intentionally add the latency, right? Like because model is thinking, right? Like we just do sleep for 420 milliseconds. And how does it work? Let's open our browser and then see. Like this is how it's going to work. It's going to say data. This is a live event test from GDG Warsaw 2024.
Quick question about the kind of synchronization of clients. Let's say you've got 100 clients. How is it synchronized? Each client gonna the message is going to be delivered to each client at the same time, or there is some latency?
The time they start, this function starts, right? Like the events function start for all of them. If you have 100 clients, all 100 will receive all these, because we're saying that they will receive all of it. But if you have, for example, in the request, you can get the user, you can get their email, identify the user, and then get their query, and then execute the query, and then send a response like for the request, right? Like you can do this as well. So that means like if you make 2 connections to this, both connections will receive the same thing. So let's do a demo. I know demos don't work, but let's try. So I'll open this project. This is literally the same code we wrote, right? And then this is the HTML. I'll show the HTML, by the way, before we show. Like I don't have to, by the way. So let's run our server. In Go, you do go run your file name, and it will just run it. Right now, the server is running. It's not. We didn't print anything. That's why it's empty. So if I zoom in, can you see it? OK, we'll go and then open localhost 3000/events. And I want you to take a look. Right? Anytime token is ready, we're just writing to the response. If I refresh a new client, it's receiving the same set of data. If you do it again, it's because we fixed it, right? We set it as hard-coded data. Okay, let's move on. So that's how you receive data. But what's the front end look like? Because we wrote the data in special form, with a data colon and \n/n, right? Like every message is separated by 2 new lines. But the front end looks like this. I'm not really good front end developer. I wrote my HTML5, and you write your H2 and then P's, and in like JavaScript, we have the event source. You don't need to include any library. You don't need to import it from anywhere. There's event source. Event source is already available in the browser. In most browsers, in most modern browsers, you have event source. And all you do is just specify the location. Voila. You can listen to every message that comes. Like every time there's a new message, it will call onMessage. It will call onMessage, and we just add the data to our paragraph. So let's do a test, and that's how it works. If you think this is fake, let's do our local host 3000. This is literally how it's working. If you look at the code, it's a bit different than I just showed because I wanted better font, of course. Why not? There's an on error I had to write because anytime we close the connection, anytime we stop serving the data, it actually reconnects. The event source actually retries all the time. It wants to keep the connection open all the time, right? It's not like it finishes. It wants to keep the connection all the time. That's why anytime server closes connection, front end, the client opens again. That's why I said like if it's an error, that means it's disconnected. After it's disconnected, I just want to set it to empty string. So it restarts again. But you can do other things, right? Like you can keep the connection open and send the events anytime you want to send the events, but keep the connection open. So far, so good. What more use cases? Like if you just mastered event source, like you just mastered there's something called server sent events, right? Like server now can send events to client. This is cool, right? Like what more use cases can we have? If your application ever works with real-time data, you can now display real-time data. Anytime there's a change, you can push the change through the stream. I'll show you one project that I built last year. I was giving a talk. How many of you were last year here? Oh, 2, 3, 4, 5 people? Yeah. So I was giving a talk about JPRQ. JPRQ is a ngrok alternative. It's a proxying tool. Like it lets you serve from your computer. So I built this project, and we built debugger. We built the debugger, and I'll show you what the debugger does. So let's open our terminal. So last year, during this talk, we built meme project. Meme project is just you get a random meme. That's it, right? Go run main.go. Oh, we have to stop the other server. Stopped it. Let's run it. So now the server is running. Can you open localhost 3000 on your phone? Of course not. Of course not, right? Of course not. You need JPRQ. If I say JPRQ -s 3000, now you can open this meme.jprq.site. So try opening this. You should get a random meme. And keep an eye on this page. Anytime anyone is opening, try different page, jprq.site, and then try write something. I know we are being recorded, so be polite. Yeah, 1, 2, 3. Right? You see, every time you're entering something, the debugger is showing it. And are you getting some memes? I hear no one laughing. Okay, let's open the. Someone got this meme, I'm pretty sure. Who got this? Anyone got this? Yeah, he got this. Yeah, he's showing on his laptop. Yeah, we can debug requests which is coming and going. So this is the debugger that we built with Jastrovic. He's right here, like 2 years ago or like two years ago. And when we figured out that event stream is such a cool thing, you can make your applications real time. And the code is that simple, like 2 more lines. And it's so fun. Like if you're a junior developer, I tell you to like build some real-time apps, because when you have built real-time apps, it doesn't feel like a junior developer, right? Like it feels much better.
Yeah, I don't want to interrupt you. I was just curious regarding receiving the events. Is it guaranteed to be delivered? Is there some kind of acknowledge underneath the hood? Or is it like, I just send it, whoever got it, who didn't because of some network issue, that's fine as well.
So event source, like we just saw, like SSE is server-side events, is on top of HTTP. It's literally HTTP. We're just writing to HTTP, but we're not closing the connection. We're just writing new things whenever it's available. And HTTP is on top of TCP. And TCP has this guarantee that like your packets get delivered. It's not like they got lost, like you use UDP. That means if you're using TCP, if you have the connection open and the client is open, there's a good chance that you'll receive this message. And it's just same way you make a request to your server, right? If your server is up and running, if your client is healthy, they're going to get the messages. There's a guarantee that like control transmitter, right? Like there's TCP that makes sure that packets get delivered so that your message gets delivered. Yeah, like so far we didn't miss any of the events actually, because like it was open. And look what happens now. Like if I go to the tunnel, which is JPRQ is open right now, and close it, it says now it's offline, right? Like it knows exactly when it's open, when it's closed. So if we have SSE open, that would say online. Because it's closed now, it will say offline because there is no connection to the server now. Your client can know if like the SSE is open or not.
Yeah, I have a quick question also regarding SSE itself. So in the commercial development, I didn't really like face with SSE really much. And the question is like, how does it behave on scale? Let's say if you have millions and millions of users, do we have any limits of the number of connections overall?
That's a really good question. So we used actually SSE in production. So let me show you. So you've tried LeetCode probably, right? Like here I am working at Google because I did LeetCode. And anytime you write code and then you want to get your code tested, like there's multiple test cases that it has to run. So this project that we built earlier, like is being used by a few thousand developers every day. Like it has 15 test cases at least. And every test case result is submitted through SSE, right? Server-sent events. And we have tens of thousands of developers using it every day. And they don't complain about SSE failing because it's on top of HTTP. It's literally the same code that I just showed you. Like we flush the response. Anytime the client is healthy, that means they receive it. And it does scale. It does scale so well because you can scale HTTP servers easily because they're stateless, right? Like you don't have to keep the state open or closed. WebSocket is on the other hand. We'll talk about WebSockets very soon. It's harder to scale. You can still scale it, but it's not as easy as SSE.
But what's the actual difference, right? So both SSE and WebSockets needs to capture the connection of the particular client, right, to provide the message continuity.
Yep, we have slides for this. Exactly the difference between the two, when you should use one or the other. So if you are here, like if you know about Kubernetes, you can actually use the Kubernetes server. You can watch resources. Like they built, we built actually, right? Like if I say Kubernetes, the API server, that's my team, like the control plane, there's like actions you can watch. You can watch certain resources. Anytime you need the updates from Kubernetes API, you can call a watch request. And it's also through get with query parameter watch. Anytime you open a watch connection, that means you're just like waiting for the updates. Anytime there's an update, you receive it. Like you can have this pops up in place. So the debugger we just saw, is actually open source. You can go to GitHub and see the code, and it's as simple as we just saw. This is literally the code that makes the debugger this cool. So you just set the content type to be event stream, and you write the header. That means you stopped writing the headers, and you just write the data to the response, and you flush it. And don't forget to flush. Exactly, like you should always flush. It's a thing. So let's move on. Yeah, link is here. If you open this link, you would see the code. So we talked about event stream. It's real time and it's unidirectional. What does unidirectional mean? It means that browser initiates the connection, right? Like it requests something the same way HTTP request is. Like it's just requesting a resource. It can specify what resource it wants to watch or like see updates for. And then server will send one by one, like all the updates. That's why it's called server sent events. Like server is sending the events. And now let's talk about WebSockets. What is it and how is it different from server sent events? WebSockets is also real time. Like you can send back and forth messages. It's bidirectional. That means you can, like server and the client can talk to each other. So browser initiates the connection to server, and then they can back and forth send messages. It's bidirectional. That means if browser has more updates to send to server, it can also send it. It's like it can send messages. So that's WebSockets in general. And your question, when which, right? Like when do I use event source? When do I use WebSockets?
I have a question on MQTT, somewhere between them, like pops up kind of protocols.
This is definitely about browser, right? Whatever the browser has, and browser does not have MQTT because it's for mostly IoT devices, right? IoT devices have this protocol. And same way, you can implement actually real time outside of browser very easily because you have TCP. For example, if you're building a mobile application, you don't have to use any of the protocols. You just use TCP and build your own protocol on top of it. It's much easier that way. MQTT, like if you're an IoT device. But if you're on a browser, you're limited to choices, these two choices. Event source, event stream, or WebSocket. So let's compare the two. So who's going to win? So unidirectional, bidirectional. If you need real-time updates from the client as well, that means you cannot use SSE. But you can, actually, you can make requests, right? Like additional requests. That means you're going to open additional connections, but still you can make bidirectional using event source as well. If it happens rarely, for example, let's say user interacts rarely, but most of the time it just receives updates, then you can also use event stream. So event stream is actually pure HTTP request. It's literally HTTP. Like it's nothing new about it. It's just HTTP requests that keep happening, right? Like it keeps sending events. It's pure HTTP. There's nothing wrong with using event stream. But WebSocket is a bit weird. WebSocket is actually starts with HTTP. You make an HTTP request, and it actually responds with a status code or 101. Right? Was it 101? That means switching protocols. So that means servers receives the request, and it says, I want to switch now. Like I want to change, and it just changed the protocol of the communication on flight, during the request, right? Like it changed a different protocol called WebSocket. And WebSocket has its own connections, like there's handshake, there's like, it has to upgrade, like a lot of things that happen inside WebSockets. It starts with HTTP and then later switches to WebSockets. Because WebSocket is not text-based. HTTP, as you know, is text-based, right? Like you can write responses, and it's not that easy to write bytes. Well, we can, but something you can write as a text. Event stream, on the other hand, you have to encode it. That means if you want to send additional data, that means you have to somehow encode, serialize it into some text format so that you write data colon and then something text writable, right? On the other hand, WebSocket supports binary. And this is good if you're working with binary data, like large chunk of data. Because we worked with a lot of throughput, I realized that like just serialization itself costs a lot of CPU, costs a lot of consumption to, serialize, deserialize, serialize, deserialize. And I remember there was one request to JPRQ that was like downloading 60 megabytes of PDF file. That was like blocking every other request. Why? Because it was trying to decode it to base 64 and the CPU was burning. Like, have you tried decoding 64 megabyte PDF file into base 64? Like, it sucks, right? It's so slow and your computer burns. That's why I use binary. When you have to use binaries, use WebSockets. That's where WebSockets wins very well. There's much less overhead. Scaling it, there's much less overhead, like reading the code, understanding what's happening. Did we use any library? No. We just wrote to the response, and that was it. Like, you didn't use any library. In WebSockets, we use libraries, we use upgrades, and it can fail a lot of things. Like, I'll show you how it may fail as well. There's more overhead. You have to like spend extra effort, like supporting WebSockets. I would say event stream, as we saw, is much simpler. And there's native support from browser. Same goes for WebSockets, but it's a bit more complicated as it has this switching protocols plus some handshakes that takes some time. And all the time it's like hell to debug a WebSocket connection. It just closes the connection and doesn't say anything. It's like, I'm not doing this anymore. Like, that's how WebSockets work. It just closes the connection. It doesn't tell you why. On the other hand.
I have a question about speed.
Mm-hmm.
On a user session, let's say 5 minutes, so it's a large amount of messages. Can you say they have both speed or even stream a bit faster, maybe?
I would say,
direction of messages?
so regarding speed, depends on your code as well, of your server and client. Because WebSocket switched protocol, that means it's pure TCP now. It doesn't have to do like parsing for HTTP. It does its own parsing. And it's purely byte-based. And it's more optimal. Like, if you're trying to send millions of events, I would say somehow WebSocket would win. Because it's purely byte-based. It's purely TCP on top of TCP. It's not HTTP anymore. HTTP, as you know, is not as efficient because it's text-based and it has to do the parsing to be readable. And yeah. More questions?
What if a client loses connection and you have to it has to reconnect to grab more data? Then which of the two is better for that?
Event stream, actually, SSE does it for free. As we saw, like, it keeps connecting all the time. It doesn't want to be disconnected ever. It keeps connected all the time. If the server is alive, it will keep the connection open. If the server is not alive, it will just send connection requests nonstop. But for WebSockets, that you have to do it yourself. I've seen that browsers are doing it natively, but you can't guarantee. There could be old browsers that's running and it doesn't retry. So you have to like retry the connection on your own when you're using WebSockets. So both cases, if you want the connection open all the time, that means you have to make sure the connection is open.
Let's take example use case. Let's say you want to create like a Kahoot-like experience,
Mm-hmm.
like was live, right? So
Yep.
which of those would you choose or recommend?
I would choose WebSockets because Kahoot is users also engaged, right? Like, users also choosing some things. It's like, it's bidirectional. You can actually make HTTP additional requests to Kahoot, but it will not provide like, it will do additional calls, right? Like, it may take additional time to open the connection. Like, TCP, it has to establish the TCP connection. It takes additional time. So WebSocket, I would say, is much better, would provide much better user experience for Kahoot.
Even though it might suddenly scale a lot because of spikes of users, right? That's why I was thinking maybe event stream is better because of the scaling mechanism.
You can scale WebSockets too, but it comes with a state. That means you have to now think which user is connected to which server so that you write down to the response, right? Like, there's this thing, and event stream as well. If you scale vertically, it's no problem. But if you scale horizontally, that means you have add more and more servers. You have to know which server your user is connected to, so that you write from that server to your user, right? So that case, we can talk about like a scaling part at the end. But it's a really good thing, because like one machine can actually take millions of connections. There's no limit to number of connections it can receive. The problem is if you have million threads open, like from a one machine, it's not going to scale, right? Like we have to think better. Like Go has Go routines that's way more scalable than threads are. That means you can have a lot of connections open from one machine, but still it's still limited. If you reach 100,000 thread Go routines, you still reach this bottleneck. If you have millions of connections open, you should use a different thing called there's like what you can do is just make your I/O event-based. But we can talk about this. Like WhatsApp did it in 2010. They made one server keep the connection for 1 million connections, and a year later they did it for 2 million or 3 million. I can show you. Like WhatsApp, 1 million connections. So they did it in 2011, sorry, 1 year later. And then in 2020, they did it to 2 million connections. One machine. One machine has 2 million connections open. That means it can right now, if you have one machine running, it can talk to 2 million people. If you have to send update to one of the 2 million people, you can actually tell the one server and it will just deliver it for you. And WhatsApp did it. Yeah, like you can host the biggest Kahoot game in the world. I actually researched on this topic, like how they achieved 2 millions. The furthest I went so far was 500,000 connections, which was also good. Yeah, like JPRQs itself, because it has thousands of tunnels open and it receives millions of connections per month, it has to scale, and it's just running in a $5 machine. And it can still scale to a few 100,000 connections at a time, which is really good. That's why we use Go, right? So let's move on. So Kahoot was a really good use case, right? Another thing is chat apps. If you're building chat applications, that means you can use WebSockets. Or any app that has collaborative approach, like drawing apps, apps that you have to send to someone, your peer. For example, this slide application is also using underlying WebSockets, because it has to, anytime I change the slide, it has to change all the open sessions for other people, right? Or Google Docs or any other technology that you use on the web uses WebSockets when it has to be collaborative. Like any real-time updates. For example, let's say you show stock prices. Stock prices change a lot, right? Like you have to show the ticks. Anytime there's a change in stock price, there's a tick. So that means you can stream the ticks using, actually you don't need WebSockets here. Why did I write here? You can use SSE here, right? Like you're not sending from the client, you're just consuming it. So this is the wrong place. So you can use SSE here instead of WebSockets. Or football match, if you're watching football match, you're seeing the real-time updates, you can also use SSE here. And election results, again, SSE.
Yeah, so but basically SSE is HTTP based, right? So there's like some extra overhead over every message, right, that is coming theoretically. So WebSockets, if you're talking about stock prices, maybe like this milliseconds can be a reason why to go with the WebSockets.
Yeah.
Another question that I wanted to ask. So WebSockets, they are switching the protocols, right? And does this switching the protocol, does the handshakes and keys exchange once again for for encrypting every message that is coming to server or from the server?
Handshake only happens once. Handshake happens only after switching the protocols to WebSockets. So it's it's done only once. So the connection is open. Server and client has agreed, and then every message is just binary that's coming and going. There's no in-between handshakes between messages.
But from an encryption encryption perspective, right, so they should be encrypted, right? So it's most likely based on the
TLS, yes.
Right, so it's during the handshake, they need to exchange the keys as well.
Actually, this happens during HTTP. Like when you open HTTP connection, you're like serving TCP over TLS, right? Like because WebSocket is using TCP as well, using TLS, that means there's not going to be like this certificate handshake. It's different handshake than we talked about. Like HTTPS has its own handshake, right? WebSocket has its own like sort of agreeing to things, right? Yeah, that's a good question. So there are different different handshakes, one for HTTPS and for WebSockets. And WebSocket, whenever you use WebSockets with HTTPS, it's possible. It's like all the messages you back and forth send also is encrypted, right? Like using the same certificate that you used, because underlying TCP connection is encrypted using TLS.
And for example, if socket connection is got broken, right, you need to reconnect. Do you need to do handshaking again, or it's like all set already?
You have to open a new connection, and you have to do everything all over again. So, and it's not that actually slow, as I say it. It's like milliseconds, and like round trip. Let's say wherever your server is. For example, let's say the server is running in Warsaw, Google Cloud. That means the round trip is going to be like 80 milliseconds. 80 milliseconds is not something you can, say, oh no, we have to use WebSockets over like SSE. No, it's like a few milliseconds, and it's okay, unless you're working with stocks that you need immediate, every millisecond count case. So online terminal, something I built recently, like it's been over 2 years now. Why would I build online terminal, right? Like who would need online terminal? The case was that I'm lazy. I'm not a front-end developer, and I don't want to build UIs. All I want is just take the PyTest application and put it online for students. They have their own code. I let them test their own server. Let's see a demo. And then it will run PyTest against the server that you
command is running, and it will real-time show you which tests are failing, which tests are passing, and it'll show you this nice output. When it's finished, it just closes.
Two things. First of all, I hate building UIs. That's why I brought the terminal instead to the browser. Second thing is that it's real time. User does not have to wait until all tests have run and show the output, right? That would be horrible user experience. That's why I wanted them to see the status of their tests real time. Two things. That's why I had this motivation to build online terminal. So how did I build it? Like this is another real-time application. This is SSHing into the computer and then streaming the result in the WebSockets. Why WebSockets? Because user can also interact with the terminal and also send the events in real time. So first of all, you need to choose a library for WebSockets, and there's so many of them. It's not like SSE where you can just write a response and be done with it. You have to use some additional library, and there's like a bunch of them. The Golang.org is actually now included in the standard library, if I'm not mistaken. That means you don't have to have like additional dependencies. And I hate dependencies because you have to patch them, you have to take care of them yourself, and you have to install it somewhere. Like, I don't like dependencies, but you can choose one of them and then stick with it. And it's the same HTTP request that we receive. It's the same handler that we just saw when we wrote hello world, right? We receive the request and response, and we work with it. And in WebSocket, we have to accept the connection. Like, turn the connection into WebSockets, right? Like HTTP into WebSocket. That's when we do upgrade. We pass HTTP connection, which is this request and response, and it turns it into WebSocket connection. In between, the switching protocol happens. And I had to disable the compression mode because it was failing in Safari. It was working fine in Chrome and Firefox, but in Safari it failed. Why? Because it was gzipping, and gzipping is not supported in Safari when you use WebSockets. This one line took me a whole day. And if you cannot accept it, sometimes it happens. That means no WebSockets today. And you defer. In Go, there's something called defer. It's like cleaning up. Whenever you're done with it, you don't do it later. That means you'll do it at the end of the function call. Close the connection, open connection, so that you don't have leaked connections. That's how WebSocket works. And when you have the connection, you can receive messages, send messages, do anything you want with it for each request. There's another protocol I wanted to talk, but I can't because we're almost out of time, which is WebRTC. WebRTC is real-time communication. That means it doesn't happen as slow as WebSockets or server-send events because it works, so to say, peer-to-peer. For example, let's say we're doing a video call or audio call or anything that we're doing streaming, something similar. What we can do is utilize a new protocol that's WebRTC that's available on your browsers. That's how actually when you meet people in the browser, that's the protocol that's used. How does it work? There are stun servers that help you find out each other because peer-to-peer is really tough thing to achieve. You cannot connect one machine to another together in a simple way. You need discovery servers. The two peers should know each other, somehow connect to each other, right? And that's how WebRTC makes it possible. In between, there are some servers that it communicates about and then find each other, and then now they can share messages, share files, share anything peer-to-peer. It's not so peer-to-peer because there's firewalls, there's a lot of things that sometimes there's in between servers. So you can't really tell this is peer-to-peer. And we're reaching the end of my presentation. I can tell you one thing. I've built a lot of server-sent events, WebSockets, WebRTCs, and you don't need real-time apps. You can give up. They're hard. Like scaling it, making sure that they work. You don't need real-time apps. Just tell your users, refresh the page every second.
Or you can refresh the page.
Yeah, exactly. Exactly. This is end of my file, and this is the presentation if you'd like to scan it. I'll take more questions if you have any. Mm-hmm.
Yeah, so I'm just interested, some time ago I was preparing for systems and interviews, right, and I was trying to understand how YouTube works, right, and YouTube basically splits the video into into blocks, right, and you are getting it by simple HTTP requests, right, so what do you think, why server-side events or WebSockets wasn't used there for this particular
So if I answer your question, there might be serious consequences, right? Because I work in Google and I have the access to this NDA, there's source code, stuff like this. It's let's say hypothetically, you're building service like YouTube that streams videos, right?
Okay.
It depends. The answer is it depends. You can try both of them and then compare the traffic. Which one's helping you? Because in any case, just being sure doesn't matter in development, right? Being right doesn't matter because you want to be efficient. So what you can do is split the traffic into two. Try A, this protocol, try B, this protocol, if you're rich enough, right? And then compare the two use cases and then choose the one that fits perfectly.
I have another question. So, having this in mind, right, basically selecting the protocol is quite fundamental thing, right? So, for example, it's quite hard to build one and another in the commercial world, at least, and just compare what's better, right? Are there any frameworks or any already available tools that allow you to compare different protocols for your particular use case?
So when it's web, use HTTP, right? When you need real time, but only server streams the data, use SSE. If it's bidirectional, use WebSockets. And if it's peer-to-peer, use WebRTC, and that's it. There's no more protocols because browsers are so much limited. It doesn't give you the TCP, because if you get TCP, you can build your own protocols in any way you want. Especially you get UDP, right? So you can invent new protocols, but browsers don't allow you to do that. That's why you're limited to a bunch of protocols, like 4 or 5. And choosing one is not hard. right? Like it's maintaining that makes it hard. That you have to make sure that the server is always running, right? Like you have to auto scale, scale up, scale down, and that's where Kubernetes might be helpful as well. So like to answer, yes, web is complicated, but I hope this presentation made it easier for you to understand the web. And if you want real-time support with your phone or additional like IoT devices, just use TCP and be happy with it, right? Like HTTP is also good, but at the same time could be slow or it has its own quirks, so to say. Any? Yep.
Is there a problem that server-sent events can solve and WebSockets cannot?
Server-sent event can solve, but WebSocket cannot. So WebSocket is more general. Like it can be bidirectional. That means WebSocket can do everything that SSE can do, but it cannot do it well enough, right? There's an overhead from your server side. Debugging WebSocket is hard. Like debugging WebSocket is pain because you need WebSocket client. If you use, for example, who uses like Postman or like such tools, right? And all of us use such clients, and sometimes they don't have WebSockets. And if you cannot open the connection, you never know why it couldn't open the connection. That's why, like I would say, WebSocket cannot do well debugging. Like when it closes, just closes the connection. You don't know whose fault is it, like what happened in between, no error messages, nothing. It just closes the connection, and there you go. You have to figure out yourself. Debugging is really hard in WebSockets. And SSE makes debugging really easy because literally we opened SSE response in a browser, and browser actually rendered it line by line, right? Like debugging is really easy in SSE, and WebSocket cannot do it.
If you use SSE and let's say you have 3 dashboards, so 3 types of events,
Yep.
you recommend to use one connection and just, let's say, event routing in JSON, or open three connections?
Depends on the use case, right? Does it mean if you have one connection open, should all 3 be real time? That means you can actually add types to your data, right? Like just add types to your data. That's how we did it in request because debugger, we saw there's response and request, like 2 separate events. So we added something called data type, and we just pushed it into JSON, right?
So one connection.
Yeah, one connection. One connection is a lot easier to maintain. That means, I remember in one company like 5 years ago, it was like Uber. You order your food and you see the real time, like where is the driver, and actually it was for dispatchers, so they used a lot of tabs in Chrome. There were hundreds of tabs open, and each tab opened WebSocket connection. And whenever you're running like 100 connections for each user, we had like tens of thousands of such users. That's multi-million connections. How we solved the problem is utilizing web workers. That means one entire browser can have only one connection open. No matter how many tabs you open, it will reuse the connection, like in the background. That means your app can reuse the connection from the other tabs that are open. That's how we reduced the number of connections from millions to a few thousands. So like reduced number of connections as much as you can.
Are there any new technologies like newer than WebRTC, or is it state of the art?
WebRTC was experimental for many years. I had a lot of issues like experimenting with WebRTC. I wanted to build my own like video chat application. That didn't go well. Now WebRTC is way more stable than it used to be. I don't think there's any better technology out there, but there's experimental things. That means whenever things are experimental, you can't find them in other browsers. It's already in Chrome or only in Safari or Firefox, so that means you're stuck with one type of browser. But WebRTC is becoming more and more accessible to every browser these days. So I couldn't say state of the art because it can get better soon. Hopefully that makes it a lot easier for the user. So the time is 52, so we can take one more question. And that's it, I guess. Cloud for it.
I just checked, it was there. Oh, it is, okay.